On a family friend's 50th birthday, my family was responsible for buying him special balloons for his party. So we got these huge foil balloons in the shape of the number 50, and when we went outside into the freezing cold, it was almost as if they had deflated. However, when we came inside the warm building, the balloons had seemed to be magic. They began to look like to re-inflate to their original size. This is a real-life example of Charles' Law. Here we have the Charles' Law equation, which is the initial volume divided by the initial temperature equals the final volume divided by the final temperature. Only the temperature and volume are allowed to change, not the pressure. A key thing to keep in mind when thinking about this equation is that both temperatures need to be in Kelvin. They cannot be in Celsius, so we will use Kelvin equals Celsius plus 273. So the way that Charles' Law works is that when the pressure is constant, temperature and volume have a direct relationship, meaning if the temperature rises, so does the volume. On a graph, this would be represented as a diagonal line. A good image to hold on to for understanding this law is, let's say you have a balloon with 1 liter of air. When you lower the temperature of the air inside the balloon, the particles lose kinetic energy and slow down, requiring less space. This results into the balloon shrinking. The opposite happens with hot air. When the air heats up, kinetic energy rises and the particles go crazy, pushing out from inside of the balloon, making it bigger. As we can see, this is a clear example of Charles' Law. And here we can watch the pressure stay the same, and whenever we raise the temperature, the volume increases as well. So when we lower the temperature, the volume will also decrease. The particles, when they're heated up, the kinetic energy makes them move faster, and then when they are cooled down, they tend to slow down. So when they slow down, they don't need as much space as they would if they were heated up, like here. So here's our first example problem. A balloon takes up 625 liters at 0 degrees Celsius. If it is heated to 80 degrees Celsius, what will its new volume be? The equation for Charles' Law requires degrees measured in Kelvin, so we have to convert our Celsius into Kelvin. Here you can see we converted our initial and final temperatures into Kelvin. Now that we have all the pieces for our puzzle, we can now plug in our numbers for the equation. Now that we have our equation written out, we can start solving it with algebra. The first step is to multiply both sides by 353 Kelvin. On the right side, both of the Kelvin get canceled out. Here we rewrote the equation with what we have left, and so we cancel out the kelvins, which tell us that we need to use liters in our final answer, which is 808 liters. Moving on to our next question. We see here that both temperatures are in Celsius again, so we're going to convert our Celsius into Kelvin, just like it says in Charles' Law. And here's our initial and final temperature in Kelvin. So we write our equation with our numbers typed in. We multiply both sides by 350 Kelvin. Then the 350 Kelvin on the right side cancel out. So we're going to go ahead and rewrite that equation here. And then the Kelvin cancel out, leaving us with milliliters to include in our final answer, which is 700 milliliters.